Okay, today we were learning how to clear fractions. So for instance, this should be a no-brainer for you. There we go. Everybody, start by clearing that denominator. Once you're done with the first step, it won't be fractions anymore. Then it'll be a quadratic. And then it'll either factor or it won't. If it doesn't factor, quadratic formula. I know it's got a lot of little steps, but they should all be easy ones for you. So your first step was you multiplied everything by x. That canceled that. 5 plus 3x equals x squared. And then you wanted to get everything onto one side. Personally, I would have moved it all over here because I don't like my lead term being a negative. So I would have said 0 equals x squared minus 3x minus 5. Because I would have subtracted 3x from both sides, and I would have subtracted a 5 from both sides. All right? Now, that doesn't factor, and therefore, I'm going to use quadratic formula. X equals negative b, which is 3, plus or minus the square root of b squared, which is 9, minus 4 times 1 times negative 5, all over 2a, which is 2. And then you should have said x equals 3 plus or minus square root of 29 all over 2. Raise your hand if you had that one right. Awesome. That's the base. That's the, like, you got to be able to handle that. That's like the simplest kind. All right, now we're going to step it up a notch. What if it was 1 over x plus 1 plus 3 equals 2x? Well, still, the common mistake here would be kids think, oh, I got to multiply by x and by 1. No, you want to multiply by x plus 1. And so I'm going to do that to each part. I'm going to put it in parentheses. I think you should too, because that'll keep you from forgetting to distribute. Like here, you got to distribute the 3 to both of them. It just adds a little bit of algebra. Just a little bit extra algebraic manipulation. 1 plus 3x plus 3 equals 2x squared. That's what that times that is. Make that squared a little more clear that it's a squared. And then that times that plus 2x. Once again, you got to gather it all to one side, set it equal to 0. And you know what? I'll save you the pain. You don't have to go put it into the quadratic formula. Just get it equal to 0 and see if you get the right equation. Personally, I'd move all this stuff to the other side. That way you can keep your lead coefficient positive. Because see, if I move this to this side, I'm going to get a negative 2x as my lead. And then it makes it a pain in the butt to try to factor. It can be done, but it's just a pain. You should have said 0 equals 2x squared. And then when this 3x comes over to the other side, it becomes a negative 3x. With 2x makes negative x. And then the 3 and the 1 both become negatives, so it becomes negative 4. Raise your hand if you had the right equation. Good. And I trust from there you could have either factored or what? Quadratic. All right, good. Now let's take it up one more notch. What if we had this? Except, don't even write this, just watch. What if we had that? Do you get I just have to multiply by x and x plus 1? Okay, but see, their problem is going to be, it's going to be buried. It's going to be like this. And again, if you just multiplied by x squared plus x, it would have worked. But here's the extra complication they will add to the problem. They will also have an x here. That is a typical question for today. So what do you multiply by? X plus x squared plus x, or what? Remember, these little sayings that I keep coming back to are said for a reason. If you can factor it, you should. Do you get that that part can be factored? Please rewrite this problem with just that part factored. And I think you'll see what two things you need to multiply by everywhere. We pretty much, in the complicated, even the most complicated ones, we don't ever make you multiply by more than two things. You should have said 1 over x times x plus 1 equals 2 over x plus 2. There we go. All I did is simplify this part right here by factoring it. And now that makes it more clear to me anyway, that do you get that multiplying everything by x would fix part of my problem, but it wouldn't fix the whole problem? And if I multiply by both x and x plus 1 everywhere, then it'll fix both parts of my problem. That cancels that, and that cancels that. So 1 equals that x cancels that x, and don't forget to distribute this now. 2 times x plus 1 is 2x plus 2 plus, and distribute that out, 2x squared plus 2x. And then it's just about getting it all onto one side and setting it equal to 0. And then again, with quadratics, it's either factor or quadratic formula. So I'm subtracting 1 from both sides. And what's this grand total make here? Well, 2x plus the 2x would make 4x. And the 2 minus the 1 would make 1. So 2x squared from here plus 4x plus 1. Now that one might factor. I'm going to check it quick, just to remind you how that would go. Can't take a 2 out of everything, so I got to go like this. 2x and x. And then how do I make a 1? It has to be a plus 1 and a plus 1. Now to the outside and the inside, oh, so close. The outside and the inside make a total of 3x, not 4x. So, doesn't factor. Let's go to the quadratic formula. The quadratic formula needs to be like the easy part now. In higher algebra, it's like the whole point. You're like, oh, we got to do the quadratic formula. Here, it's you do a bunch of work, and then you get to this point, and then you do the quadratic formula. It's like just a small ending part of the problem. Okay? That's pretty much all there is to it. So we just have a little bit more complicated ones at the end, like the very last problem in your worksheet from last night. It's like those the whole time on this new worksheet. So the new worksheet is called 2.7.2. I'm going to pause for a second while we pull it up here, 2.7.2. All right, so here's typical questions on 2.7, number 2. There's only a few questions, but they're kind of intensive algebra-wise. So this very first thing, do you remember me saying something about factoring? If you can factor, you should. So let's factor this part right here. And you don't have to rewrite the whole problem. Just rewrite that one part of the problem. I bet you anything, it factors to those two things, that and that. Let's see if it really does. X, I really don't know the answer, but I assume it probably does. Let me see if x plus 5 and x minus 2 would work. First, outside, inside, last. First would be x squared. Outside and inside would make plus 3x, and the last would make negative 10. There it is. Now do you get why? Because now I can multiply everything by those two things. And if I multiply by x plus 5, and here's a little trick I like to do, put one on one side and put the other on the other side. This just gives you a little more room to write. X plus 5 on this side of the 1, and then x minus 5 on that side, or no, x minus 2, sorry. And then x plus 5, x minus 2. Then, that one cancels that one cancels that one. And what's left at the end is just a 7. That cancels that. What's left is just, and be careful now that if there's a minus out in front, that's a classic way to get you. That plus means that these are both positive here. So, sorry, there's nothing there, but this is all positive, just x plus 5. And then the last part is just those canceled, and I have a 3x times x minus 2. 3x times x minus 2 is going to happen and go right there. Okay, so that's 3x squared minus 6x plus x plus 5 equals 7. This is about being careful and grinding out, not making little errors. There are times in your life where you will need to be careful. A lot of times you can get away with a few little mistakes. You're driving down the road. Do you think it matters much if you're off of the center of the lane by 2 inches? No, it doesn't matter much. But there are times where you make one little mistake. You make a wrong turn. You go left instead of right. And all of a sudden you're going down a one-way, the wrong way, and you can get killed. So there's times when it matters. If you're a brain surgeon and you're off a little bit, believe it or not, they can be off by a millimeter and cause you to lose function in your arm or something based on poking around in your brain. They can be getting rid of a little tumor or something and be off like a millimeter, and bzz, you just lost some function for the rest of your life. So there are times you gotta be careful. Today's lesson, it's not hard. It's just being careful with negatives and stuff. Like right here, that negative is gonna goon so many people because they won't notice that it has to get distributed on the thing that we multiply by everywhere. So when you're multiplying everything by x and x plus 1, and x plus 1, if you don't distribute those negatives, they'll get you x and x plus 1. And I should do it here, but really, 0 times anything, it's going to make it equal 0 anyways at the end. So anyway, just be very careful because the mistakes you'll make will be on the negatives and the little things like adding like terms. So remember, we're not done with this puppy yet. This one's 3x squared minus 5x. I'm bringing that 7 over to the other side and I'll make it minus 2. And it's probably worth checking to see if they factor because the person who made these worksheets really likes factoring. And so a lot of times you'll find that they will factor. And if they factor, they're so much easier to do than the quadratic formula. I'm going to show you, since we have time today because it's such an easy day, a kind of a cheat way to do it. You want the ultimate way to do these quadratic formula problems? You do the square root part first, the b squared minus 4ac, before you even factor. Because if b squared minus 4ac works out perfect, then it will factor. Okay, so if I just quick do the quadratic formula on it, don't even try to factor it. If I want to know if it factors, b squared minus 4ac tells me. So b squared would be 25 minus 4 times a times negative 2, and that's the b squared minus 4ac part, right? And if that comes out perfect, we'll know it would have factored. 12 times 2 is 24. 25 plus 24 is 49. Square root of 49 is 7. That means this thing factors. Now, the bad part is you've already done so much work that you may as well just finish the quadratic formula, even though you know the thing would have factored. Okay? Because now I know it's square root of 49, and that's 7. So now I just may as well just finish off the quadratic formula. Negative b is 5, plus or minus the square root of that, which is going to turn out really nice, all over 2a, which is 2 times 3 is 6. So it's 5 plus or minus square root of 49 is 7, all over 6. And then you just got to do 2 parts, one with plus, one with minus. 5 plus 7 is 12. 12 divided by 6 is 2. And 5 minus 7 is negative 2. Negative 2 over 6. Negative 2/6 turns out to negative 1/3. So there's 2 and negative 1/3 are your 2 answers for that one. Now that, obviously the factoring wouldn't have been super clean because we have an answer of negative 1/3. But. All right. So there's the typical questions for today. And I'm going to scroll up just to see if I can see any more types of problems that I haven't covered for you. I'm pretty sure I got it all, but yep, still the same kind. And this is just a little bit of a review. And it's basically saying, look at the graph and see which ones could work. I'll help you with one of these. Do you get, if the 2 possible solutions are listed, it's either that or that. I know the answer is either negative 5 or 2. And then I'm supposed to use the graph to decide what the actual answer is and which one is extraneous. Look at my graph. Do you know where the answers are? Because I do. I know where all these answers always are. If it's not two lines crossing and you like see where they touch, if it's not that, then it's the roots. Right there, that's the root. The root's 1, 2, 3, 4. -5 is the root. If the root's -5, well then what's this one? There's a name for it, extraneous. Yeah. If this one's actually the root, and that one, it's extraneous. Okay, remember the roots are the x-intercepts. That's what they're trying to reinforce with you at the end. All right, that's all I got for you for today.